Good morning, everybody, and thanks for showing up that early. I guess the other people had a really great time yesterday evening. So, yeah, my name is Timo Stollenwerk. I'm a Plone core developer, and I will talk about test-driven development with Plone. Before I start, I have handouts and an example package with all the tests that I will show, so I don't have to show too much code on the slides. I will give you the URL at the end of the talk, so you don't have to take pictures or write down everything. So testing. The first time I came across the idea of automated testing software was around like 2006. I went to the office of a small Plone company where I work, and my boss was running some kind of code that I couldn't identify. Like there were lines of code running on the monitor, and I was wondering, hey, what are you doing? And he was saying, like, I'm running automated tests. And he explained then to me, like, the idea of automated testing software. And I thought, yeah, I mean, sounds like a good idea, but pretty advanced. I mean, I've been in Plone for like 2 years or something. So I was like doing some part of my development still in the ZMI and everything, and tests just seemed too advanced for me. Back in these days, we had like a customer that was like the second biggest saving bank in Germany. So I thought, okay, this is like big business enterprise stuff. Could be interesting, but yeah, I didn't look into it really any further. For like 1 or 2 years, I think, and then I had to write my diploma thesis in computer science at Bonn University, and I had to do a proof of concept for my diploma thesis about XSLT, an XSLT transformation, which was pretty complex, like many different XSLT styles and files and everything, and I was constantly breaking things. I mean, XSLT is pretty hard, at least for me, and I was like breaking things over and over again. So I thought about like, wow, this testing idea. I mean, I could like write some tests, and it would prevent me to break things every time I try to write new code, right? So I started it was just an XSLT transformation, so I just started with writing some very simple tests that just started the transformation. And at the end, I had an XPath expression that checks for the output, right? So that worked quite well, actually. I didn't break things any longer. So this is one of the big advantages of like doing tests in general. But for Plone, even though it was like a good experience, I did not really start to do this in my regular daily work with Plone. I don't really know why. Maybe it was like, yeah, I just wasn't used to it. So who here is at that stage in the audience? Like, you know about like this testing thing, but you're not doing this on a regular level with Plone? Okay, there's hope for you. I hope I can convince you to do the next step. So yeah, what do we get by just writing tests? We get code that works, we get proof that it works, and we get a lower defect rate, which is also pretty important. We all know that it's pretty cheap to fix bugs at an early stage in development, and that it's pretty expensive to fix them afterwards, after we deploy it and everything. And tests give you a feedback very early at this stage in development, so you can fix bugs really easy and cheaper in the long term. Yeah, exactly. Documentation, yeah. I will come to that. Okay, so test-driven development. At that stage, I thought that test-driven development would refer to the fact that you write tests, right? It's like that. Maybe it's because I'm not a native English speaker, but test-driven development is really something different. And I saw what test-driven development is at the Solventus sprint around 2009. I just applied for a Google Summer of Code, where I wanted to write a new discussion framework for Plone Up Discussion. And it was like one week before it started. And I went to the sprint in Sorrento. And Leonard Regebro paired up with me at the sprint. And we were like thinking about like the lower level implementation of Plone Up discussion, like how to actually store the comments like on B trees and stuff like this. And we sat together, and Leonard is really experienced with Zope and everything. And yeah, he sat down and said, okay, let's follow best practice when it comes to testing. Let's write a test first, right? So we first wrote a test, really simple. Then went over to the implementation, and we went on like this. And it was really like, I was sitting next to him, and I was really like relatively new in the Plone community. And he went over and over with that approach, and I was like sitting like this. I never saw that before, and I never read about like test-driven development, but I was really sure that I wanted to work like this. And I will give you like a short introduction and an example of how to do test-driven development. I mean, the thing about test-driven development is that it has like just a few rules that are really easy to follow. But to actually do this is like a bit harder. But I will try to introduce like the basic principles of test-driven development. The first rule is do not write any code without a failing test. So you really start with writing a test first. Here's an example of a really simple function. We have a function that just tests if a given string is a palindrome. Like if you read it from left to right, like from right to left, right? So we write a test like this. We have an assert statement where you basically say, I want this to be true, what is inside the brackets. And if it's not, the test will fail. So when we start with the test, we actually start by thinking about what we want to do, which is a good thing. Most programmers, me included, love to just start coding. I mean, you have the feeling that you do something, but it's really important that you think about what you plan to do before you do. And test-driven development forces you to do that, because if you write a test first, then you have to first think about like, what kind of function do I have? What variables do I have? How do I name it? So we have this test here, which just says we have a method is palindrome, and if we give it the string noon, it should return true, right? So the next step then is we make the test pass quickly. And quickly is really the key word here. In test-driven development, you try to do like really tiny steps. So you don't think about how this method should act like in general. You just try to make this single test pass. And the easiest way to do this is just return true, right? Because like you know that you will give that the test has like give you noon, and you know you want it to be true, so you just return true. Done. It's like you have a green light. Then you go on and write a second test. So now we give the isPalindrome method foo, and we want it to be false because it's not a palindrome, right? So we want this test to pass, so we have to actually write an implementation, right? So what we do is like we compare, we check the string, if it's the same, if we just revert it, and if so, we return true, if not, false. So we get 2 passing tests, right? And now another important step comes, which is sometimes forgotten, but it's really important. It's the refactor step. As I said, you always try in test-driven development to make tests pass as fast as possible, which is a good thing because you don't have to think a lot. You just try to make it pass. And the refactor step is the step where you step back a bit and think about how could I refactor that code? Because if you have this approach that you try to make a test pass as quickly as possible, then you end up with a lot of duplication usually. So this step is really important, that you refactor things, that you have clean code. And this is just 1 line of code in comparison to like these 4 lines of code. It's really easy to read, right? So what do we get? We get an extremely short development cycle because you have like these short iterations, which is really satisfying and it's really fun because like if you don't work with test-driven development, what you usually do is like you write a lot of code, then you start your Plone instance. It usually fails. Then you fix your code so the instance starts. You create a Plone instance. You try things out, and this takes a lot of time, right? And at the end of the day, you can be happy if your code works. If you do test-driven development, you have like really short iteration cycles, and you can stop basically at any point you want because like they're so tiny, those steps. You can stop, and what I usually do is I stop with a failing test because then when I come in the morning, I mean I can leave at any point, right? I don't have to stay at the office around like 8 p.m. or something because I just can leave because I have a failing test, and at the morning I just run my test and I see the failing test and oh okay, I know where to start, right? I don't have to warm up or anything. So it's really rewarding. But apart from that, we got clean code that works. I mean, if we just write tests, we probably get code that works, right? But if we do test-driven development, because of the fact that we can refactor it, we get really clean code that works because we have the refactor step, and we can make sure that we clean up our code after each step if we have to. It's not necessary, but it's really easy to refactor because you have trust in your code. You can trust in your code. If you don't have any tests, then it's really hard to refactor because you're always afraid of breaking things. But if you have tests, you can just refactor like crazy because all the tests will tell you if you break something. That really gives you a lot of trust in your code in the long term also. And this is really something that is important and that's really rewarding and that pays off in the long term. So this was more theoretical. It was just like a plain Python method that I showed to test. So how do you test in Plone? If you haven't wrote tests in Plone and you just start now, you can be really happy because nowadays we have a really good package that is called Plone Up Testing. It is very well documented. Martin Aspelli wrote it. It's really easy to start with. So this is an example of a Plone Up Testing test. It's just a class, and you see there a layer. Plone Up Discussion has this this idea of different layers. If you write tests, usually you want like different things. Sometimes you want to have like a full Plone instance with just everything because you want to like write a high-level test. You want to test everything. But the problem with that is that these tests take some while, right? If you want a full Plone instance, it just takes some time to make it running, and you want your tests to be fast, so you can have these short iteration cycles. So sometimes you need like less. Maybe you just want to test something on the ZOAP level or ZODB level, and Plone Up Testing allows you to set up these different testing layers where you can tell every test what do you want. And this is an integration test for Plone Up Discussion. It has this example TDD integration testing fixture, which just sets up a Plone instance. So you can choose from different layers, and you can even write your own code to set up like more things. I will come to this in a minute. Then this test class has a setup and a teardown method, which is not there. These methods are, the setup method is called before each of these other methods, test methods that you see below. So you can do like a certain setup. At line 14, you see now a first test. It just sums up 1 and 3 and has this assert equal statement. Before I had this assert true statement, you have like 3 or 4 different assert statements, which is just assert true if it returns true, false, and assert equal. So you want 4 to be equals to the sum, right? And this test will just pass. One bit of theory. If you have, like I told you that you have like different test layers in Plone, right? And if you write tests, you have different kinds of tests. This is like, you probably saw it before, it's like a food pyramid, right? On the top are the things that like sugar, things that you shouldn't eat that much. And at the bottom is like bread and all the healthy things. So at the top, we have functional tests. Functional tests are really high-level tests. You have to set up the entire Plone instance and everything, so they run really slow. So we want some of these, but not too many, because then our tests run too slow, and we can't really do these short iteration cycles and really test-driven development. Then we have integration tests. Integration tests, you mostly write integration tests in Plone, because Plone is a framework, and what you usually do is you write some component that you want to integrate, a dexterity type, an event handler, or something like this. So most of the tests are really integration tests. For integration tests, you still need the full Plone setup, right? Because you're testing the integration, so you need Plone. At the bottom, there are unit tests. These are tests that I showed you before, like the palindrome. Unit tests are a bit hard to do in Plone, because you usually don't develop on that low level, right? So you have to mock a lot of things. I will come to that in a minute, to each of these tests types. So an example, if you write a dexterity type, you want to test it, right? And we want an integration test here. So we don't have a high-level functional test. So we don't want to test it from the outside, like going to what you usually do if you write a dexterity type without any tests. What you do is you write code, then you start your Plone instance. You go you install your add-on product. You go to the start page, and you go to the add menu, and you try to add the dexterity type and see if it works, right? You basically test manually. If people say they don't test, they lie, because they test manually. It's just not efficient, but they test. So an integration test tests the integration of your dexterity type. But it does not test it on a high level, but on a lower level. You have like one test for each kind of functionality that you have. If you write a dexterity test, and I have this as an example in my handout and in the example package, you have a single test for each of these things. So this means you have a single test for your schema. You have a single test for your factory type information. You have a single test for the factory. You have a single test to add this type, and you have a single test for the view. What is the advantage of like an integration test like this in comparison to a high-level test? If one of these tests fail, you know exactly where to look. Say if the factory test fails, you know that something is wrong with the factory, right? So this is really a nice way of using tests in Plone, because this is like what I do usually with these standard integration tests. I just copy and paste them, because they're all the same if you start writing a new dexterity type. And I always do errors when I write dexterity, because it's a lot better than archetypes, but it's still like a bit boilerplate code. So you do typos, you forget things, and if you have these tests, they show you exactly where to look, and it's really fast, because you don't have to test manually. You don't have to set up your Plone instance. You don't have to go there and everything. You just run the tests, and they're really a lot faster than doing it manually. So unit tests in Plone. They're at the lower level, at the pyramid, so we want to do them a lot. As I said, the problem is that when you write unit tests, you don't have any Plone. So what do you want to test, right? I mean, if you write like a dexterity type and you want to test something, what should you test? I mean, the low-level tests are all in dexterity. You don't want to write unit tests if you write a dexterity type, for instance, because there's nothing you can really test. So what you have to do if you have like these lower-level tests is you usually need mock objects. Mock objects are like simple implementations of the components that you work with. This is an example of that I wrote I wrote collective MailChimp. MailChimp is a mailing list software, like software as a service, and this is the integration for Plone. So I wanted to test all you have like a portlet and a view where people can type in their email address, and then it's registered on MailChimp. I could test the real thing. My test could call actually the MailChimp API every time I run them, but then my test wouldn't really test the code that I write, and it would depend on like the servers being up. So I don't want that, because it takes too long. So what I do here is I create a mocker object. This code uses the Python mocker library. There are plenty of others. So for each test, I create a mocker object that replaces the postmonkey import. This means that in any code that you write, when it's tested and you do an import postmonkey, it does not import the real postmonkey API that actually calls MailChimp, the MailChimp service, but my mocker object that I create, and I say, you can call it like 0 times, 2 times, 100 times, this is this count, and then at where the points are, you actually define what methods this mocker object has. So you have a postmonkey object, and then you can say, okay, if I call like my postmonkey dot lists to give me back all my lists, then it will return a dict, right? So if you do that, you can write your tests easily, and you will test the right thing, right? So next thing is functional testing, the thing on top of the pyramid. Functional testing is black box testing. Black box testing means that you can test things only from the outside. You can't look inside. You're just testing like on a real high level, which means in Plone, we're doing web development, you're testing with your browser, right? You don't care if like a method is implemented correctly or works correctly. You just care about like if you create a dexterity type, you just care about if I click the add button, do I see a dexterity form, right, to add my type. So functional testing is also really important, but since you test on a real high level, they take some while, because if you want to test them manually or automatically, you have to fire up your browser, you have to fire up your Plone instance and everything, so they take some while. So you can't really use them for test-driven development, because as I showed before, like test-driven development, the idea is to do short iteration cycles. And if it takes like 10 seconds or something to run a functional test, you don't want to wait like for 10 seconds every time you change something, right? Then you don't have these fast development cycles. So Martin Fowler calls functional tests the second line of test defense. The second line because if you have a failure in a high-level functional test, then it not only shows you that something is wrong, it shows you basically like only a red light. It just shows you, hey, here's something wrong. It does not point you to the right into the right direction where is something wrong. It just says, okay, something is wrong. You can guess it then if you look at the tests a bit, but not as good as like an integration or a unit test. So this means that if you have a failure in a functional test, this means you have a missing unit or integration test. The good thing about functional tests is that it's really testable specification and also documentation. So functional tests really come handy if you're working in an agile environment. So if you have user stories with your clients, and they wrote it down, something like as a user I want to log in or something on my site, then you can take this user story and take it into a functional test. So if you talk to your customer, and the customer maybe after you implemented something comes and says, this is not what I wanted. I mean, or something like, it's not working, right? Clients always come to you and say, hey, there's something not working. If you have such a functional test, then you can just point them to this functional test, and functional tests should be written in a way that regular people can actually read them, right? So you can point them to the functional test and say, hey, this is our specification, our documentation, this is what we agreed on. So if you want to change, we can do that, that's not a problem, but please tell me, what would you like me to change? And this can really save your ass. I mean, once I had to write a single sign-on system for like a bigger client, and the single sign-on integrated Plone with an MP3 shop. And the client came to me and they were saying like, the code that you wrote is not working. And I was like, okay, what exactly is not working? I tested it. I actually run the test against a live system, because if you're single sign-on, it's hard to test, but you can run tests against like real systems, so I did that. And I could prove that the single sign-on service was not working. And the only thing, it really took me only 5 minutes. I mean, at first when I saw the email, I was really afraid that, wow, I did something wrong. But then I just ran the tests, and I sent them those tests and to the other company. And then there was nothing, like for like a couple of weeks. Then they sent me an email again, and I was like saying, here's the specification, what shall I do? And they said, okay, it's still not working. And I was like, okay, then I will just run my tests regularly. And it was like another 2 minutes or something. So I set up a script that every 5 minutes or every 2 minutes, run those tests against the real implementation, which you should be really careful if you do that. You can't just take your regular test and do that. But in this case, these tests did not change anything. You just had you had a login and you tried to log in and see if you're logged in the second system. So I ran it regularly, and I saw that it was failing like every couple of hours. It was just failing. And my test showed me that the single sign-on servers of this other provider was not working properly, and I just sent it to them. I just sent them the output of my test. It turned out that it was like their servers. They had like many different servers, and the time settings on the server weren't right. So in case when I would not have those tests, then it would really took me probably weeks to figure that out. But with this test, it only took me in some 10 minutes or something. So this really can save your ass and can save you a lot of time if you have these functional tests. Functional tests in Plone have been misused, in my opinion, with Zope test browser, because the idea of or not Zope test browser with doc tests. I mean, probably who here writes doc tests if they write tests in Plone? Okay, not many. Good. No. I mean, it's doc test is the right thing because it's the way we do functional tests. But the problem is that people, if you usually look at a functional doc test, they're really long, and if they break, they don't tell you where exactly to look, right? And another problem that we had for a long time is that Zope test browser can't test JavaScript. So we needed something that can test JavaScript, right? And we have something now, thanks to the hard work of Godefroy Chapelle, Asko, who's here, Ed Manlove, and many others. We have now an acceptance testing framework for Plone, which I'm quite happy with. As I said before, ideally acceptance tests should be readable by your clients. You could even try to train your clients that they can actually write functional tests, because that would be the best, right? Because you could just tell your customer, hey, please write down a specification. I mean, that's not how it works in real life, but that would be cool, and it's important that people can actually read those high-level functional tests. So in Robot Framework allows you to write high-level functional tests in natural English language, more or less. This is an example of a high-level Robot Framework test. You just look at it and you see what it tests, right? It says test valid login. And if you have given a login form, if you have a login form, if you enter your valid credentials, then you're logged in, right? This is really easy to retest, and you just read it and you know exactly what it does. Compare that to a regular doc test, which is 200 or 300 lines. You never get what is supposed to test. I said that Robot Framework allows you to use these keywords. I mean, if you have a thing given a login form, there's no way that Robot Framework, which is just a generic testing framework, can know what you wanted to do, right? Because what is a login form? So you have to specify that. And you have to specify this for Plone, right? Because you want to test it in Plone. If you say given a login form, in another system, if you have a Drupal system or whatever, this means something completely different than in a Plone. So you have to tell Robot Framework what's a login framework. What does it mean if you say given a login form? So you define those keywords that you defined in your test case in these keyword sections. So you say a login form means go to, and then you Plone URL and a login form, right? This is basically the same what you do in Zope test browser. And okay, and this yeah, like it's like in Zope test browser. So you have like these a bit lower level keywords like go to, type in something, click on something like in Zope test browser that you can use to define these higher level keywords for a test. Nevertheless, I mean, you could just go and write all your tests in these lower level keywords, which are actually Selenium 2 keywords. But you want your tests to be readable, right? And it's a good thing if you start to write your test without thinking about how to implement the test, actually. Because if you just write it in natural language, then you think about how to write it in a way that people can actually understand. And you have to think about what you want the system to test or what to do, right? So start with the high-level test and just write it in natural English language, and then think about the keywords, how to implement them. I will now show you a short... I will now run this. I have this test that I just showed you that just calls the Plone login form. I have it here. I run it now. Robot Framework uses Selenium 2 internally, which means that it tests a real browser. In this case, Firefox. So it fires up the Plone instance, types in like the credentials, and you see you're now logged in, right? This is just this test. And as you can see, I mean, it took quite a while, right? But it's still a lot faster than doing this manually. And this was just a really simple test. We already wrote a robot framework test for Deco, for Plone Up Toolbar, for Plone Up Collection. And then you have like many tests. And they take quite a while, but it's much more efficient and much faster than testing this manually. And you can do it like in a repetitive way, right? In a comparison, I would like to run an example unit test. The example that I showed at the beginning in the test-driven development part is the unit test. It took, like you see here, that it took like 26 seconds for this really easy integration test to run, and now this is the unit test. You see, I mean, if you want to do test-driven development, you should write unit tests or integration tests because they're a lot faster. If you don't write like these low-level tests, then what you usually do is like you put a PDB inside your tests, right? I mean, you want to test something and you don't know how it really works or how it should work, so you put a PDB in there and you like work with PDB and command line and everything. If you have like really fast running tests, like when it takes like 2 seconds or 3 seconds, you don't even need a PDB because you just write a line of code, you run this test, you will get an error message, and you fix it and you write the next one. So if you want to do real test-driven development, it's extremely important that you have fast running tests. Yeah, I showed you how you can write unit tests in Plone, or I give you an idea. How to write integration tests. Examples are in the test package that I will show you in a minute. And I showed you how you could use high-level robot framework, how you can write high-level robot framework tests to do acceptance tests. But of course, there's a lot more. I can't get too much into details, but you have like things like continuous integration, which means that on every time you check in code, your tests are actually run. Because like if tests take some time, the Plone test, for instance, take like 40 minutes or something to run. You don't want to run them on your local machine because it just takes too long. So you commit something and then Jenkins will run on a dedicated server and it will write you an email if you broke some of these higher level tests. You have like Travis CI, which is also a continuous integration tool, which is really nice and really, really easy to set up for add-on products. So if you have written an add-on product and you have some tests, I can highly recommend to use Travis CI. We also have a talk about Travis CI. So if you have tests and you're add-on product developer or core developer or whatever, go there, go with Travis. We have Buster.js, which gives you unit tests for JavaScript, which is also quite nice. If you develop a lot of front-end stuff, then you should look into Buster.js. It's really nicely integrated now into the Plone test runner, like Robot Framework is also. Both can, like both Buster.js unit tests for JavaScript and robot framework tests are now integrated into the test runner, which means that you can just call bin test and it will run your all the tests. Then you have like things like performance tests, for instance, like with Grinder or Funcload. Some books I can highly recommend. They have nothing to do with Python or anything. Just about like test-driven development. The one on the left side is from Kent Beck, Test-Driven Development by Example. It gives you examples actually in Java and in Python how to do test-driven development in these short cycles. On the right side we have Agile Software Development from Robert C. Martin, which I also can highly recommend. It explains things like basic principles of agile software development, of extreme programming, design patterns and stuff. As I said before, every kind of test that I have is in this example package, so you can go to GitHub, clone it, and run those tests. There are examples there. In the README is also like the handout, so for every slide that I have here, I have links for you. So if you're interested in examples of integration tests, of functional tests in Plone, there are plenty of links there. If anything is missing, please write me an email, or even better, do a pull request. Yeah, do you have any questions?
I was the one that raised the hand when asked about dot test, right?
Yeah.
The thing why I write dot test is because I use them only for functional testing.
Yeah.
And because I could test and then after generate my implementation of it. Now with robot, the thing that it kind of works the same as I use them with dot test.
Yeah.
But it's a total different format. And, well,
it's a different what?
Format.
Format, yeah.
Yeah, so is there a way to kind of integrate this robot testing and keywords, especially inside the structured test? So you can then just have states created.
I mean, if you have restructured, I mean, you could just write those robot framework tests probably in restructured text. I mean, the thing is that for the example that I have is actually behavior-driven development. Wait a sec. These keywords that you see that it used like given, when, then, which refers to behavior-driven development, because you always have these keywords. Given is the precondition, when is the action that you take, and then is the actual test. And as you can see, the keywords are not given a login form, but a login form. So the given is just ignored because it's a keyword. So we could like adapt robot probably to ignore certain things. But actually, I mean, I pointed that out. I would prefer to write tests in robot framework a lot more than we used to do it in Zope test browser so far, in doc test so far, because it's a lot more readable to have these test cases, because you can, if you have like many test cases, right, you have like 20 or 30 different test cases, and every test case is only a couple of lines of code, and you encapsulate all the nasty details in your keywords, then it's a lot more readable. I mean, think of it, if you have like 30 tests in a Zope test, in a doc test, you have to read the entire page. If you do it like this, you just have on top of it the test cases you can just read, and if you're interested in how they're actually done, then you can look at the keywords. But in my opinion, that's a far better way to do this. I mean, but you raised a valid point. Like, we want our documentation to be testable, right? So we have to think about ways how to do that. What we can do is, for example, like Robot Framework gives you, can make screenshot if tests fail. And we can use these screenshots in our real documentation. We can just include them in our swings documentation. But I think, I mean, this is really more a matter of documentation. I'm pretty sure that Robot Framework can handle that, because it's like, so far, every problem we had with Robot Framework was somehow solved. And every time we were thinking about, wow, that would be cool, we found something in Robot Framework. Maybe Asko knows something, because he did a lot of stuff, but we can discuss it. maybe at the sprint, maybe at an open space, how to do this, how to have testable documentation. But from the past experience in Plone, I think it's really important to to separate these things and make clear to people that like documentation is something that is different from like testing and test-driven development. We shouldn't mix those two. It's okay to have testable documentation, but then it should be written really like documentation with only small portions of like explanations, but not like mix those things. Like in ZCC form, for example, where you have like tests and documentation, and nothing is really done right. I mean, the tests don't really show you what goes wrong, and the documentation is also not perfect because it's like written like a test. Yep.
I've actually been very fond of doc testing, and I know that sort of wave of sentiment is turning against it. But to me, the problem with doc testing wasn't you thought it was documentation at the same time, but that if you saw documentation as just being sort of a narrative way to write your tests, it was just it could be a style that would help you explain what you were doing better than just simply writing code where your eye would focus on the code rather than the text.
Yeah, actually, you can just write SOAP test browser tests in Python code, right? There's no reason why you should have to do this in doc tests, and I like them a lot more. But the problem is still we can't test JavaScript, and I would recommend that in the Plone community we choose one testing framework. And if you work with doc tests a lot, then I would really highly recommend to have a look at Robot Framework. I think it's a lot easier, but. Yeah. I mean, the thing about testing, it's really like something that you have to learn, and that you shouldn't like. If you haven't written tests, you shouldn't go out of this talk and start writing unit tests or something in Plone, because it's quite hard. If you start with tests, I would recommend, or if you have no tests at all, you should start with some basic tests, or maybe start with these high-level Robot Framework tests, because they're a lot easier to write. I mean, one of the phrases in test-driven development is that test-driven development allows you that it teaches you all the lessons that the code have to give you, which means that if you write tests, you get a deep understanding of your system. And we all know that Plone is like a complex beast. And if you write tests and then if you write low-level tests, then you have to understand a lot of Plone, which is a good thing if this is what you want. If you are a core developer and you want to understand how things work, then writing tests really teaches you a lot. If you're an integrator, I wouldn't highly recommend to write like then unit tests. Go with integration tests. I plan to work with you on the sprint on having better SOAP scale templates, which have like which comes with tests, so you can just have a look at it. Or if you do dexterity, there are plenty of examples how you can test your dexterity type, and it's basically just copy and paste them and adapt the naming or something. So just do that. Just start with that. Having some tests is better than none. Having high-level functional tests is better than having no tests. If you really want to dive into test-driven development, then you have to write all these integration tests and even unit tests. I can highly recommend to pair up with an experienced Plone developer like I did with Leonard. It was really like an amazing experience. As I said, I was just sitting there and like watching, and I just knew that I didn't know how to do that actually, because it seems too advanced back in these days. But I knew that I wanted to work like this, and it's really like a lot of fun. It really gives you fun. Puts the fun back in Plone development, doing test-driven development. But it is advanced, and you shouldn't try too hard. If you can't write a test and it takes you too long to write a test, then just drop it. I mean, it's not a religion or something. You just try to use it so it can help you. Yeah, just my advice. Sorry, Asko.
Yeah, so I think we make things plugging the iterate fields from Robot Framework tests. For Robot Framework, also embed comments within test suites. So I think we could also encourage comment your tests to generate those from the.
Yeah, it's really great. When we tried out Robot Framework in San Francisco, we didn't have a test runner and everything, and ASCO came along and wrote this test runner integration. And every time I have a problem with Robot, then I just tell ASCO, and he he comes up with the solution. It's really awesome work. Thanks a lot. Okay, thank you very much.